Okie dokie. Here we are in the non-calc portion of the AP Calculus AB 2022 exam. And this is your typical FTC problem. So here they give you initial condition F4 equals 3. They give you a graph of F prime, and they're asking for F of 0 and F of 5. So what you're going to want to do is instantly create an integral of F prime of X. For F of 0, let's go with 0 as a lower limit, 4 as your upper limit, dx, of course. And if you're using your FTC correctly, that's just F4 minus F of 0. So that's your fundamental theorem of calculus. So yeah, you just, you know what F of 4 is, it's 3. F of 0 we want to find. And if you're going from 0 to 4, that's a semicircle, because they said so. And area of a semicircle is 1/2 pi r squared. The r, of course, is 2. So you get 2 pi, but it's below the x-axis, and you're going from left to right. So you're going to say that the value of the integral is negative 2 pi. If you move things around, f of 0 will be 3 plus 2 pi. So that's very easy, not too hard. My guess is that probably worth 1 or maybe 2 points or something like that. Maybe 1 point for the setup and 1 point for the answers, and then getting F5, you get another point for that one. So that's that one right there. And then by the same token, if you want F of 5, you're going to be integrating from, we'll say from 4 to 5 in this case, F prime of X dx, right? So that's going to be F of 5 minus F of 4. Awesome. F4 we know is 3. F5 we need to find. Now in this case, from 4 to 5, that's going to be a right triangle. And the base and height are both 1 and 1. The slope of that segment from 4 to 6 is 1. So because up to and right to. So the area that's going to be 1/2. F of 5, of course, is 3.5. And so that's F5. So that's part A. Part A is done. Now let's look at part B. Find the x coordinates of all points of inflection. Well, point of inflection is when your second derivative changes sign. Because we have an F prime graph, you want to see where the slope changes. Well, the slopes right now are negative. You want to see where F prime changes slope. So it's negative and positive, so definitely at 2. And even though F prime does not exist at 6, because there's a corner there, sorry, F double prime does not exist at 6. I take it back. The derivative of F prime does not exist at 6. But there is a sign change because the slope's going from positive to negative, so it's definitely happening at 6 as well. So you say 2 and 6, and again, just where F double prime changes sign, that's good enough. You're good for part B. So my guess is that's probably 2 points. 1 point for the answer is 1 point for the reasoning. Part C, they give you a new function g of x equals fx minus x. I want intervals if any is g decreasing. Okay, so you want g to be decreasing, you want g prime to be negative. Well, g prime of x is just going to be f prime of x minus 1, because root of x is 1. So then you want that to be negative. You want f prime of x minus 1 to be less than 0, or f prime of x to be less than 1. Great. It want to be less than 1. Well, just look at the graph, right? Here we go. There's a y equals 1. This is that prime graph, and you got to be below it. That totally happens from 0 to 5. So definitely at 0, and you can include 0. But you're not going to include 5 because the derivative 0 there, not negative. So that'd be the interval there. And you do have to have that spot on, because they didn't specify it, well, open intervals and anything like that. Just 0 included, 5 not included. Fine for part D, absolute. So EVT again. A little surprised they did EVT twice. Usually it happens just once in the free response, but here they did it also in number 1 as well, if the total plaza question. So you want to find the absolute minimum. So you have your endpoints, they're included. And obviously, since F prime is defined everywhere from 0 to 7, we assume continuity as well. So EVT does apply. So remember, you got to be 10% closed interval for EVT. And we'll make a table. Actually, I'll just do a table up here. So X, and this is for G, mind you, not for F, so for G. But remember, G involves F. So you're going to use 0 and 7. Then remember, we already found F of Well, we know f of 0. So g of 0 is going to be f of 0 minus 0, which is really just f of 0, which we already found anyway, which is 2 pi plus 3. So that's done. Then g of 7, well, that's just f of 7 minus 7, right? That's not that hard. Well, first off, we got to figure out what f of 7 is. So we have to integrate this from 4 to 7, because that's going to be the integral from 4 to 7 of f prime of x dx. Well, that's not exactly that yet, but it's going to be f of 7 minus f of 4. So we find f of 7 that way. F of 4 we know is 3. F of 7 we need to find. And then the area from 4 to 7, we have a right triangle, we have a square, and another right triangle. That right triangle is going to be 2, I believe. That's going to be 0.5 and 1, so you get 3.5 for that area. So f of 7 will be 6.5. So you got to do some work for that one. And then we do have a critical, well, where do we have our critical point? We kind of found it in part C in a way. Remember, this is for g of x, right? So you want g prime to be 0. So that means that in g prime, remember, is going to be f prime minus 1. So you want that to be 0. So you want to know where f prime equals 1, right? That's where f prime is 1. F prime is 1, obviously, right here at 5. And at 7 also, we already included the endpoint. So you definitely have to do at 5, not at 4, at 5. So it really helps to write that and then solve for when g prime is 0. So f prime has to be 1. So if we already did this at 5, we already knew it was negative 3.5. We did that in part A. So they want the minimum value, and that's clearly the minimum. And there you go. And that's your answer. And justification, we said EBT applied. And obviously the table there acts as your justification. So that's number 3.